Welcome to The Explainer. Today, we're going to break down the absolute bedrock of automation, PLC timers and counters. These are the secret ingredients that tell machines when to do something and for exactly how long.
So let's start with a challenge, right? Imagine your job is to make a big industrial fan run for exactly 10 minutes when someone hits a button. And at the same time, you need a warning light to flash precisely 5 times. How do you even tell a machine to do that?
Well, to make that happen, the brain of the machine, the Programmable Logic Controller, or PLC, uses these awesome little tools called function blocks. You can kind of think of them like apps on your phone, each one designed to do one specific job really, really well.
Okay, so here's our game plan for today. We'll start with our automation challenge, then get right into what timers and counters are all about. We'll break down the different kinds of each, and then, the fun part, we'll put it all together and solve that fan and bulb problem.
So the real trick here isn't just turning things on and off, it's about giving a machine a sense of time and quantity. We need to build instructions that are based on how long something runs and how many times an event happens.
First up is the timer function block. Honestly, the best way to think about this is like a programmable stopwatch living inside the PLC. It's the key to making anything happen on a schedule. So what does it actually do? Well, at its core, a timer waits for a signal to tell it to go. Then it just runs for a specific amount of time that you've already set. And when the clock hits 0, bam, it triggers an output to make something else happen. It's the classic wait, then do move of automation.
And what's really cool is how simple it is when you break it down. You've got IN, that's the start button. PT is the preset time, that's the countdown you set. Q is the output, the thing that happens at the end. And ET is the elapsed time, so you can always see how far along the timer is. Simple, right?
Now, let's switch gears to our second essential tool. This one also responds to inputs, but instead of measuring how long, it measures how many.
Yep, we're talking about counters. These things are the absolute workhorses for tracking stuff. Think of items on a conveyor belt, or the number of times a robot arm has moved. Every time an input signal blips from off to on, the counter just adds 1 to its tally. Click, click, click.
This chart here shows it perfectly. See that input, x0? Every time it pulses on, the counter's value goes up by 1. 1, 2, 3. And as soon as it hits that preset value, in this case 3, boom! The output, Y70, kicks on. It's that simple.
And hey, look familiar? Just like timers, counters have a similar setup. You've got your CU for the pulse to count up, a PV or preset value, which is your target number, a Q for the output when you hit that target, and, super important, an R to reset the count back to 0.
Okay, so this is where it gets really fun. A timer isn't just a timer. You see, they come in different flavors, and their behavior changes depending on exactly what you need to do. The two big ones you're going to see all the time are the on delay, or TON, and the off delay, or TOF. The on delay timer waits for a bit before it does something. Think of a motion sensor light that only turns on after you've been standing there for a few seconds. The off delay does the opposite. It keeps something running for a bit after you've turned it off. You know, like the interior light in your car that stays on for a few seconds after you shut the door.
And then there's this little guy, the pulse timer, or TP. This one is perfect when you need to create one clean, predictable signal that lasts for a very specific amount of time.
So what does that really mean? It means you hit the input and the output turns on for, say, exactly 2 seconds. It doesn't matter if you hold the input button down for 5 seconds or just tap it for a millisecond. You get a perfect 2-second pulse. That's it. It's all about that initial trigger.
And just like with timers, counters also give you a couple of different ways to operate, which gives us a ton of flexibility. So you can either count up to a target with a CTU or count up counter. That's great for when you need to say, hey, after 10 boxes go by, start the tape machine. Or you can count down from a number with a CTD, a count down counter. That's more like, okay, start with 5 items, dispense 1, and count down. 4, 3, 2, 1, and stop.
All right, time to bring it all home. Let's circle back to our original challenge with the fan and the warning light and see how we can build a perfect solution with these tools.
We're going to do this in 3 easy steps. First, we'll lock in our goal. Then we'll build the logic for the timer, and then the logic for the counter. Okay, first things first, let's just get crystal clear on what we're doing. We need the fan to operate based on time, and the bulb to operate based on a specific number of flashes.
So for the fan, we grab a timer. It's the perfect tool. If you look at this diagram, this is called ladder logic.
You can see when our start signal X0 turns on, it starts the timer T0. We'd set that for our 10 minutes. And once that time is up, the timer energizes the output Y70, which is wired to our fan. It's a classic wait then act situation.
Now for the bulb, we bring in a counter. Every single time our program tells the bulb to flash, we also send a little pulse to the counter's input, X0. And as you can see in the logic here, once that counter, C20, hits its preset value of 5, its output turns on, letting the system know, hey, we're done. The flashing sequence is complete.
And look, this is so much bigger than just fans and bulbs. These simple, powerful blocks are truly the foundation of almost any automated sequence you can think of. They're what control traffic lights, bottling plants, elevators, you name it. They give machines the ability to react to the world based on time and quantity, which is a huge deal.
And that's the power of these fundamental building blocks. Thanks for watching. Now that you know the basics, I've got a question for you. What automation puzzle are you going to go solve?
Let's study more and like, share and subscribe for such more content and comment something you want to learn.